In this lesson, we are going to cover the volume of pyramids and cones. First, we're going to start with the volume of a pyramid. Okay, so the volume of a pyramid is the area of the base times its height divided by 3. All right, a pyramid is exactly 1/3 of a prism with the same base. So that's why we're going to divide it by 3. All right, let's try a couple of examples here. So in this example, we have a square pyramid. All right, we're going to take the area of the base times its height and then divide it by 3. So the area of the base, our base right here is a square, so that's going to be length times width times its height and then divide it by 3. So I'm going to call this 11 its length, this 11 over here its width, and this is the height right through the center of that three-dimensional shape. All right, that's its height. So let's plug that in. It's going to be 11 times 11 times 11, and then divided by 3. We do that properly, and we get approximately 443.6 repeating. So around that to 0.7, this would be centimeters cubed. Okay? Now, let's remember that the area of that base can be a number of different things. It could be length times width. It could be 1/2 base times height if it's a triangle. It could be 1/2 apothem times perimeter if it's a regular polygon. So be careful and keep your eyes open for that, okay? In this next example, all right, we have another square pyramid, and volume is area of the base times the height divided by 3. All right, the base again is a square, so that's going to be length times width times its height divided by 3. All right, since this is a square base, all right, all its sides are 10, so this would be the length and width here. Okay, now remember the height is right here in the middle, all right? And that's an unknown value. So we're going to try to figure out what that is by using the other given information. This 12 meters right here, okay, that's the slant height. All right? Slant height, we use that for surface area, not for volume. Okay, we want this. So what I'm going to do is I'm going to take that triangle right here. I'm going to take that triangle out of here, and let's move it out here. This is my height. This is the slant height that's given down the side of that face right here. Okay, and then the bottom of the triangle is going to be halfway across that base, which is going to be half of its side, which is 5. Okay, so now to figure this height out right here, we're going to use Pythagorean theorem, which is again a squared plus b squared equals c squared. All right, I'm going to call my height a, this 5 right here, the other leg would be b, and of course c always has to be the hypotenuse, which is across from the right angle. So h squared plus 5 squared equals 12 squared. I'm going to go ahead and calculate that out. And when we get that, we get the square root of 119. Okay, square root of 119. So I'm going to leave that as is. I'm going to leave it in radical form because I don't feel like writing down the whole decimal. So now I should be able to plug everything in, calculate it, and get my volume. So again, length was 10, width was 10, and the height right here is the square root of 119, all divided by 3. If we get that calculated correctly, you should get approximately 363.6, and that would be meters cubed. Okay, so that's how you find the volume of a pyramid. Those are two examples that our pyramid were squares, square pyramids. Okay, now let's talk about the volume of a cone. All right, find the volume of a cone. A cone is exactly 1/3 of a cylinder with the same size base. All right, so the volume of this is going to be, again, the area of the base times its height divided by 3. But the area of the base is always going to be a circle. So we can have a fixed formula in for the area of that base. Since it's a circle, it's going to be pi r squared times its height divided by 3. So this is our formula for the volume of a cone. So let's try a couple of examples. Try this first example here. Volume equals pi times the radius squared times the height divided by 3. Let me draw this out, and I'll plug in what I know here. It looks like the radius of that base is 13, so I'll put that in for r. And the height is 8. So I've been given all the information. Now, my first answer I'm going to put in terms of pi. And it looks like it's not going to be a nice round number for us, so I'll go ahead and calculate pi in there. All right, we get 1,415.8. That would be inches cubed. Let me double check that work. All right, looks like that checks out. So let's try another example here. Here we have a cone that's kind of flipped upside down, almost looks like an ice cream cone. And its volume again is pi times the radius squared times the height divided by 3. Now the radius in this case, 4 is the diameter, so that means this radius is going to be half of the diameter, 2. The height is down the center of that cone, okay, which I don't know. So again, I'm going to use this triangle here to figure out this height. And again, I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. All right, so a and b are going to be the two legs, h and 6, so I'll call h my a. H squared plus 6 squared equals, oh, sorry, that's a mistake. Check that. H and 2 would be the two legs, so it'd be 2 squared, and then c is the hypotenuse over here, 6 squared. So I'm going to go ahead and calculate that out and try to get my height. And in radical form, not simplified, would be the square root of 32. All right, so I'll leave it as that, so I don't have to worry about writing down decimals. Now I can calculate my volume for the cone. Do that properly, you end up getting 23.7. And that would be inches cubed. So that's a quick lesson on the volume of pyramids and cones. Remember, a pyramid and a cone is exactly 1/3 of a prism or cylinder of the same base, depending on what you're looking at. So don't forget to divide it by 3, and I hope you got something out of today's lesson. Thank you.